Hello friends, in this session we are going to discuss about the fundamental operation of algebra. Which are the fundamental operations of algebra? When you are solving any mathematics problem, the fundamental operations is most important. If you don't have fundamental operations, we can't solve even one questions in a CET or anywhere. So let us discuss the fundamental operations. So mainly the fundamental operations is nothing but very simple. So there is addition, subtraction, multiplication, division. So what is addition? Before taking addition, operations of matrices, let us take first term. The first one is a term. So what is a term? The term and algebraic expressions. The term is defined as, so for example, let us give an example. So you easily we can understand the concept about the terms. So there is a 3x, it is a term. There is a 4x plus 2. There are two terms. 4x is the first term and 2 is another term. And here, let me take one more example. 3x square minus 4x. So what is the coefficient of x? It is nothing but it's a coefficient. Coefficient. Here x coefficient is 3. What is the coefficient of x here? It is 4. What is the coefficient of x square? It's a 3. What is the coefficient of x? It is minus 4. Note this point. The coefficient of x is what? Minus 4. Correct? So this is what are terms. So we can say it is a expressions. So we can easily find the expression. Yes. Let us take the addition concept. First, let us take the addition. The first one is addition. So, which are the concepts are there in the addition? So, addition, that is a variable and constant. So, which are the variables? As you know, variables are denoted by either x, y, z. This is nothing but it's a variable. And 1, 2, 3, etc. Here also A, B, C, D, small letters, all the variables. So this is a 1, 2, 3, 4, 5, x. This is nothing but constant. That is nothing but constant. Those are the numbers. We are representing like what? Numbers. So addition of here, additionally mainly there are two types. It is a like and unlike terms. Like terms and unlike terms. Let us take like terms first. What is a like terms? So there is a like terms. Like terms, here we are adding the two numbers. We are adding the two variables. And one more important thing, when you are taking a variable and constant. So for example, sir, x is a variable, y is also variable, z is a variable, a is a variable. So if you are taking 1, 2, 3, 1, 2, 3 is a constant. If it is x, 3x, that means it is 3x. Is it a variable or constant? Yes. Here 1, 2, 3 are the constant, x, y, z are variable. Here 3 and x constant variable. No, it is also known as 3x. 3x is also known as what? Variable. Is also known as variable. So what is the definition of like terms? The like terms having the base and exponent. The base and exponent should be the same. Then only it is possible to add the two like terms. So for example, x plus x, it is a like terms. This is what a like terms. X plus x. The base is also same and this is what exponent. Otherwise, kommel baritirala. Adana is an exponent. Otherwise, we can also say it is the power. It is a power 1 and is a base. We can easily add the coefficient. We need to add the what? Coefficient. What is the coefficient of x? It's a 1. Coefficient of x is 1. There's a 2 times of x. Like that we have to add. This is what are like terms. Let me take another example. So there is a 2x plus 4x and that is equal to. Okay. Like terms of addition. Just we are doing the what? Addition. 2x plus 4x. Yes, first we need to observe. Is it a variable is same? Yes. And degree is the same. We can write 1. If here x to the power of, see, when you are writing the variable, so we have to know the division divided by it is always 1. The coefficient is always 1. and exponent is always 1, like that. Okay, we need to know all the concept. X anta idralli the highest degree is 1 anta, and coefficient is also 1, and divide by 1 ಏನಿದೆ ಅಂದರೆ 1 ಅಂತ ಇರುತ್ತಲ್ಲ ಅಷ್ಟೇ, ಸಿಂಪಲ್. And 2x plus 4x, you just add. First we need to see the definition of like terms. That means the x and x, the both are same variable and degree is also same. And what is a coefficient here? 4 and 2. You just add the coefficients. 2 plus 4, that is a 6. That is a 6, that's it. Okay, let us take one more example. So third example. So third one, there is a 4x to the power of 3 plus 8x to the power of 3, and that is equal to. Yes, is it possible to add the like terms? Yes, the like terms we can easily add. What is the definition of like terms? It is the same variable and degree should be same. Ready? X and x. Yes, q and q. Yes, you just add the coefficient. What is the coefficient of x cube? 4. Coefficient of x cube? 8. So 4 plus 8, that is 12. So that is a 12x cube is an answer. Simple. Okay. Okay, we will take a next concept. The next concept is the like terms and unlike terms. Unlike terms of addition. So what is the unlike terms? What is the definition of unlike terms? Yes. So before taking a definition, I'll give an example. X plus x square, and that is equal to what? That is equal to what? Here the variable is same. Is it a degree same? No, degree is not a same. Hence is it possible to add? No, it is not a like terms. It is a unlike terms. Unlike term we are not possible to add ಮಾಡಕ್ಕಾಗಲ್ಲ ಅದನ್ನ, because here it's maybe the base. This is what a base ನೋಡಿದ್ದು, this is what a base, and here indices, power, exponent, ಏನು ಬೇಕಾದ್ರೂ ಹೇಳ್ಬೋದು. x square 1 ಇದೆ. So here it is not possible to add this like of terms, add ಮಾಡಕ್ಕಾಗಲ್ಲ. So because it is the same variable but degree is different, you can't add. So second example, x plus y, and that is equal to. Is it possible to add? Sir, here degree is also 1. Here degree is different, but base is same. Here also it is not possible to add. The degree is 1, degree is also 1. Is it possible to add? No, the base is different here. What? The base is different. Hence, it is also not possible to add. Understood? It is also not possible to add. This is what the unlike terms. Let me take one more example. Third one, x square plus x plus y. Yes. What is the answer here? Is it possible to add these two terms? No, because the degree is not equal, but base is what? Equal. Is it possible to add first one and last one? First term and last term? These are the terms. There are three terms. Note this point. If algebraic expression, this is what expression, those are the expressions. Algebraic expression containing only one term. Say for example, there's a 4. See x. It is known as monomial. It is known as what? Monomial. In an algebraic expression containing one terms, in algebraic expression containing only one term, it is known as monomial. Monomial terms. So for example is 4x y square z square. Only one term, it is known as what? Monomial. Sir, if it is two terms? If it is two terms, it is bi is nothing but 2, right? So it's a binomial term. So example 4 plus x y plus z, the two terms, algebraic expression containing two terms, it is known as binomial term. Clear? So if it is three terms, trinomial terms. trinomial terms. Yes, example, x plus 4x plus y plus z, trinomial. And if it is more than 4 terms, it is nothing but polynomial. More than 4 terms, 5 terms is also polynomial, 6 terms is also polynomial, etc. Those are the what? Polynomial. Let me repeat. Algebraic expression containing 1 terms, monomial. Algebraic expression containing binomial, 2 terms, it is binomial. 3 terms, trinomial. More than 3 terms, polynomial. Correct? We are adding what? Monomial, binomial, trinomial. I'll give an example. Just we are taking the what? Binomial terms. Understood? The like terms, let me define addition of matrix clearly. The like terms, it is defined as the base is same and exponent is same. Here the base is same, exponent should be the same. Unlike terms, if maybe the base is same, exponent is different. If exponent is same, the base is different. It is known as unlike terms. Is it possible to add the unlike terms? No. Is it possible to add the like terms? Yes, possible. Okay. So we'll move on to the what? Subtraction. The next one is the fundamental operation of subtraction. Yes. Yes. Here also, so there is a like terms. Here also the first one is like terms and the next one is unlike terms. Then how do you define the like terms? The like terms is defined as, here also same thing, the base is same and degree should be the same. Example, here it's a 4x minus 2x and that is equal to 4x minus what? 4x minus 2x. So it is a like terms? Yes, it is a like terms. Because here the base is same, you just only observe the variable. The constant and variable is combination of constant and variable, it is also known as variable itself. 4x minus 2x. The base is same, the degree is also same. ಏನಿಲ್ಲ ಅಂದರೆ ಏನು ಬರ್ಕೋಬೇಕು? 1 ಅಂತ ಬರ್ಕೋಬೇಕು ಅಷ್ಟೇ. Correct? So 4 minus 2. Take only constant. 4 minus 2. Hence it is 2. 2x. ನಿಮಗೆ ಗೊತ್ತಿರಲಿ, ತುಂಬ ಜನ, the most of the students don't know how to add 2 numbers, how to subtract the 2 numbers. Difference. So let me write a difference here. Okay? You just note down the difference here. Plus into plus, it is a plus itself. And minus into minus, minus into minus, plus itself. And plus into minus will get minus itself. Minus into plus, just we are multiplying what? The sign. Minus into plus, it's a minus. When you are doing addition or subtraction, we have to put the greater number symbol. 4 minus 2. One more example. I'll give you one more example here before taking that questions. Okay. Here 2 plus 4. Here is a plus into plus. We'll get 6. Simple. And if it is minus 2 plus 4, minus into plus is nothing but minus. Subtract the bigger number from smaller number. 4 minus 2, that is equal to 2 itself. So we have to put a greater number symbol. Which is a greater number here? Plus. 4 is a greater number. We have plus, write in the plus. ಏನಿರಲಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಪ್ಲಸ್ ಅಂತಾನೆ. When you are writing the first number, usually we are not writing the plus symbol. When you are writing the second number, we have to write a plus or minus. What is a plus 4 minus 2? Plus into minus, minus. Make it minus. 4 minus 2 is a 2. Both are same here, correct? Both are same. Just we are reversing the what numbers. Both are same. If it is that is a 2 minus 4, is it the answer is same? No. Here the both are same. ಎರಡೂ ಒಂದೇ ಥರ ಬರಿಬೋದು. It is known as commutative property. 2 minus 4, plus into minus, minus ಮಾಡಿ 2 ಬರುತ್ತೆ. We have to put a greater number symbol. Greater number symbol. Clear? Yes. And let us move on to the like terms of subtraction. And 4x minus 8x, and that is equal to. Is it a like terms? Yes. The variable is same, and degree is also same. So answer is 4 minus 8. Plus into minus, minus ಮಾಡ್ಕೊಳ್ಳಿ. 8 ಅಲ್ಲಿ, so subtracting 8 from 4, will remaining is 4. There is a 4x, x variable I have to write as it is, and we have to put a greater number symbol, minus 4x. Clear? So let us take a trinomial. So there is a 4x square minus 8 x square plus 4x x square, and that is equal to, yes. So in this case, you can add the two numbers. So 4 plus 4. So 4 plus 4, that is a 8x square. So plus 8x square minus 8x square. Here also x square is a like terms. 4 plus 4 is 8, 8x square, and you just minus 8 plus 8, absolutely it is a 0, 0x square. If you are multiplying with 0, the answer is 0, 0x square. Clear? And we'll move on to the next one. So there is a unlike terms. The next one, unlike terms. Unlike terms of subtraction. What? Unlike terms of subtraction. Yes. So what is the unlike terms here? Unlike terms here, as it told, what addition of unlike terms concept? Yes, so same. Is a 4x square minus 8x. Minus 8x. X is the same variable, but degree is different. So it is not possible to add the unlike terms. Second question, p square minus q square and plus z square, and that is equal to what? Is it possible to do the simplification? No, it is not possible, because here p, q, z is a different variables. Different variables. This is what variables, right? Different variables, but degree is same. No, agala. Base is also, that should be in the equal. That means the variable should be in the equal, and degree is also equal. Then only it is not. Then only it is possible to add the what terms. Here also it is not possible. So pause the video and note it down. We'll move on to the next concept, is a multiplication of like terms and unlike terms. Multiplication. The multiplication, fundamental rule of multiplication. In a multiplication, let us take the first one. It's a like term. Like terms of multiplication. Yes. So how do you multiply the two terms, 2, 3 terms, 4 terms, etc. is a like terms. So before taking a multiplication, we have to know the law of indices formula. The law of indices formula. The law of indices formula, let me write, it's 7th standard concept actually. This is sort of completely basic concept. It's a completely 7th standard concept. If you know the this fundamental, that means the law of indices formula, then only it is possible to do the multiplication of two terms. So which are the fundamental, that means fundamental operations in the law of indices formula? Yes. So that is a to the power of n into a to the power of m, and that is equal to a to the power of n into a to the power of m. M and n are a bit different numbers. Numbers are variable, whatever it is. If a base is same, note this point. If a base is same, we can easily add the exponent. There is a to the power of n plus m. If a base is same, we can easily add the what? Exponent. Sir, if a base is different, if base is different and exponent is same, yes, there is a to the power of n into b to the power of n. See, if a base is different and the exponent is same, then we can multiply the base a into b to the power of n. A into b to the power of n. And here a into a to the power of n into b to the power of n. That is like a division also, the same thing. So a to the power of n divided by a to the power of m. See, a to the power of n divided by a to the power of m. Here the base is same and exponent are different. Hence in this case we need to take the a to the power of n to the numerator. If you are taking a numerator, we will get write on the base as it is and n minus m. Okay, a to the power of n divided by a to the power of m is equal to a to the power of n minus m. So that means if you are taking a m to the numerator, you get minus. Sir, if you are taking a numerator to the denominator, hence we are getting 1 divided by. So remaining is constant is 1 and divided by a to the power of m as it is and minus n. A to the power of m minus n. So a to the power of n na denominator will get a minus n here. So the sign will be the change. What? The sign will be the change. And if it is base is different and exponent is same, there is a to the power of n divided by b to the power of n, and that is equal to a by b to the power of n. So those are the important formulas. Those are the important formulas, and remaining formulas we can watch the law of indices concept video. Okay. So again come back to the multiplication of like terms. The multiplication of like terms, in this case, if you are multiplying the x square into x square into x square, in this case we need to multiply the x square into x square. That means x to the power of, if a base is same, we need to add the what? Exponent. So there is a 2 plus 2, that is equal to x to the power of 4 we are getting. Note this point. Multiplication of like terms. This is what a like terms, right? Like terms we can easily multiply. That is, we need to add the exponent. We need to add the what? Exponent. Let us take one more example. So x square y into x, and that is equal to, how do you multiply these two variables? Here we are multiplying the what? These two terms. Here there is a x square. Here the same variable. So just concentrate only the variables. There is a x and x to the power of 1 and x to the power of 2. So there is a 2 plus 1. So there is a x to the power of 2 plus 1, and y is only one term is there, write down as it is. Hence the answer is x to the power of 3 into y. Like that we have to solve the what? Like terms. Let us take one more example. X to the power of 3 and p to the power of 3 into, just we are multiplying the x to the power of 3 into p to the power of 3 into x to the power of 4 into p to the power of 4. Yes. How do you multiply these two terms? Yes. Here first we need to match. We need to match the x variables. There is a x variable here. So x to the power of 3 plus 4. X to the power of 3 plus 4. Just we are using law of indices formula here. And into again into p and p. So in this case there is a p and p. So there is a p to the power of 3 and plus 4. Hence the answer is x to the power of 7 into p to the power of 7 is a required answer. Like that we have to do the like terms. Hence what is the definition of multiplication of like terms? So if a base, we need to match the base and add the exponent. Add the exponent to the what? To get an answer. Yes, the next concept is a unlike terms. Unlike terms. So the multiplication of unlike terms. So is it possible to multiply the unlike terms? Yes, it is possible. So how? Look at the board carefully. X square into x. X square into x. Here also there is a unlike terms. Here also there is a unlike terms. This is what unlike terms. Okay. In this case, x square and x. X square and x is also what? Unlike terms. Correct? Because the base is same, but degrees is different. Here also the degree is different. Actually here there is unlike terms and like terms are. This is only one example for the like terms. This is also unlike terms. In this case, x to the power of, just we need to add the 2 plus 1, and that is equal to x to the power of 3. So that is equal to, let us take in a number. So there is a 3x square into 4y square. Yes. How do you multiply these two terms? In this case, we can't multiply the x and y variables. So write down the x square variables and y square variables as it is, because there are different variables. But in this case, we need to multiply the what? The constant. So 3 into 4, that is a 12. So 12x square into y square is the answer. Okay. Let us take one more example. So one more example, third one. So there is a minus 4x to the power of 4 and into 2x to the power of 2. Yes. and into, let us take in y terms as it is. Then how do you multiply these 3 terms? So there is a minus and here it's a plus, again it's a plus. Let us take in a question is if it is minus, what is the answer you are getting? First we need to multiply the sign. So there is a minus, plus, minus. Minus into minus, it's a plus, correct? And 4 into, first multiply the constant. 4 into 2, that is 8, only constant. And here x variable. How many x variable are there here? 4. That is x to the power 4 is nothing but 4x variable and x square. So totally 4 plus 2, that is x to the power of 6. There is a 6 variable. Only one y variable, hence write down the y variable as it is. This is what? Multiplication of like terms and unlike terms. Pause the video, note it down. We'll move on to the division. The division of like terms and unlike terms. Let me explain first what is a like terms. After that we'll move on to the unlike terms. So in the like terms, if it is x square divided by the same variable is a x square. Almost if it is in like terms, always the answer is what? We'll get 1. So that is equal to, here if you are taking c, so using this formula, so a to the power of n and b to the power of n, otherwise same formula, but the base is same here. So the same formula, just we are taking to the upside here, okay? And x to the power of 2 minus 2, x to the power of 2 minus 2, x to the power of 0. So anything to the power of 0 is always 1, but a to the power of 0, it is also one of the identity, there is a law of indices formula, a to the power of 0 is always 1. But note this point, a is not equal to 0. 0 to the power of 0, it is not 1. It is not 1. It is an indeterminate form. We have to call it is an indeterminate form. In this case, x to the power of 0 is always 1. So always the multiplication, that means the division of like terms is always gives the 1. So there is a 2 times of y to the power of 3 divided by 4 times of y to the power of 3. In this case, we can cancel the y cube and y cube. Y cube and y cube, and 2 1s are 2 2s are. Hence the answer is 1 by 2. That's it. So we'll move on to the next one. It's unlike terms. Unlike terms is different. So unlike terms. Unlike terms, here the 3x to the power of 4 divided by there is a 6x to the power of 8. So what is the answer you are getting here? So in this case, x to the power of 4. So there are 4x here, there are 8x here. So take up, so 3 1s are 3 2s are. So you just, we can take a numerator to the denominator or denominator to the numerator, whatever it is maybe. So there are 4x and there are 8x. If I cancel the 4x to the 8x, remaining is 4x. Hence 3 1s are 3 2s are. And we can cancel the 4x here, you can cancel the 4x. Remaining 4x. So x to the power of 4. Otherwise, we can also solve. So there is a 1 by 2 is remaining if you are taking to the numerator using this formula. So a to the power of, that is a to the power of n minus 1. X to the power of 4 as it is minus 8. The sign will be the change. And that is equal to 1 by 2 times of x to the power of minus 4. So x to the power of minus 4. Actually, one more indices formula, a to the power of minus n is equal to 1 divided by a to the power of n. So this is what one of the formula. So if you are taking the denominator to the numerator, the sign, the index, that means the power will be the sign will be the change. Okay. 1 by 2 x to the power of minus 4. This one we can also written as 1 divided by 2 into x to the power of 4. So this is what an example of division of like terms. So pause the video and note it down. After that, we will go to the main important formulas of algebra.